Hello team, today's challenge is trail traversal, where we are given effectively what's a matrix. It's not, it's an array of strings, but we're going to treat it similar to how we would with a two-dimensional matrix. And we need to determine the path through. So this is the current position, and we can take all of these t's to the goal. And then, of course, we go right, down, right, down, which is the return, right? The challenge here is that that C can start anywhere. So while it starts here in the top row, second position, index 1, the last one, which is a totally different length, by the way, if you're looking at it, the C is actually in the last row, close to the middle. Okay, so we're going to have to be flexible, right? We're going to have to account for that. It means we're going to have to jump through some hoops, but I think we can get it done. Okay. So over to the code. The first thing I want to do is talk about our neighbor coordinates. Okay, so if you're looking at the C here, our neighbors are the left, the right, and the bottom. There is no top, but we also need to take into account up. Okay, and that's what I've done with this code. I have up, left, right, and down. And this is an adjustment. So for going up, I'm going to adjust the row -1. Right? I don't adjust the column, I adjust the row. If I'm going left, it's -1 for the column, +1 for the column for the right, +1 if I'm going down for the row. Okay? So rows here, columns here. Just to make this easy on myself, I have gone and added those letters here. I've also done the opposites. Okay? I'm not fully happy with this part of the solution, but I put the opposites in here because if we go down, we don't want the next move to go back up. Otherwise, we're just bouncing up and down, or left and right, depending on which one we're doing. Okay, that's a good way to get into a trap. So we don't want that, which means that we need to be able to test against the opposite movement and not do it. That's what that's about. Okay. Down here, so into the function now, we're going to actually start the work. And the work starts with a const, which is some destructuring, okay? So right here, I'm going to have the start. The start is going to be equal to the C, right? The current position. And then we have the travel, which is a T. I'm totally double quotes on these. In every other single thing, I did single quotes. Just laziness, right? Let's let the code editor figure that out. It can change it for us. But for today, moving on, okay? The goal, right? The goal is last one. That is the G. So doing that, in fact, I absolutely hate this. I'm going to go and do this, back it up, adding those quotes, problem solved, okay? So it was bugging me enough that I'm doing it live. So here we go. We have start, travel, goal. And then up here we go start, travel, come on, spell it right, travel and goal, okay? There is a reason for this, okay? It might look strange. You might just want to go const start equals C, const travel equals whatnot, okay? There is a reason for this, and I'm going to come back to it after, because while it's not important to today's solution, it does leave things flexible for the future, okay? So I'm going to leave that there for a moment, and we are going to return to it, okay? The next thing that we need to do is find out our starting row, like this, and of course our starting column, okay? Where we are inside of that, I'm going to keep calling it a matrix, even though it's just an array of strings, okay? So inside of that matrix, we're going to figure out where we are so that we can start moving from there, okay? Because we can't start at position 1 and end at position whatever the last one is. We just can't, okay? We're starting somewhere in the middle and moving around this thing, up, down, left, and right. We're doing it, okay? Which means that we need the row. So map dot find index on this one, okay? We're going to take that row just like this, and we are going to test if row dot includes start, okay? So again, we're using our start right here, which makes it a little bit more flexible. If I decide to change start, I can just change it in the one place and it trickles down, okay? Right here, we have map again. This time we're gonna use that start row because that's our row, right? And index of start again, right? So now we have the start row, we have the start column. Only one of those is highlighting because we've only used it. We've only used that one. We'll come back to start column in a second. But we need some variables, and these are going to be flexible. We're going to change these when we get into our looping system, okay? So the first one is the trail, okay? And the trail is actually what we're going to return, so it's going to be down here, but it starts as an empty string, okay? The next one is the current coordinates. Current coords equals an array, okay? That is start row and start column, okay? Again, we want to be flexible here, so while this gets us our starting position, we are going to totally change these as we move through our matrix. I keep pointing to this one, even though that's not the matrix that we are working through. So, sorry. Moving on, our last one today is the current type, and that is the C, T, or G. Technically, once we start, we're only concerned with T and G, but we are going to set this to start again, okay? So that gets that done, and now we can start our loop. Our loop is going to be a while, okay, which is very odd and kind of scary because they run away so easily. But if we capture it well, then it shouldn't really be a problem, okay? But whiles can be dangerous if you don't have the right checks and balances inside of them to exit, okay? In this case, we're taking that current type and saying that it is not equal to goal, which is our G up here, okay? We extruded, we took that out and we used it down here. Words, apparently they're hard for me today. So that is going to be our test, okay? But we are not done because we need to be inside of that matrix, okay? Which means that we need a for, okay? This is going to be for let this of all of our neighbor chords, okay? So we're going to go and grab that. And what are we taking off here? Well, we're taking the direction, the opposing direction, the row, and the column, okay? Just like that. There's a joke in there, but I'm not going to touch it. So moving on. With that, we start to figure out where our position is. So we've already got our start position, but we need to know which direction we're moving in. And the for loop will test each one of these 4 directions, okay? Which means that the for loop can only ever go 4 times maximum. Really, really nice, okay? But we're going to test, so we're going to get the next row and, of course, the next column, okay? Next row is going to be the current chords, like this. That is index 0 plus the row, okay? Again, if the row is minus, right? Anything plus a negative is the same as anything minus the absolute nature of that negative. So not a problem. Doing the same thing down here. So current chords 1 plus column, okay? And we have both those. Now we can do our if, okay? And our if is 2 different things. The first one is going to be travel and goal like this. We're making an array and we are testing includes, okay? What are we including? Well, we're including map, next row, almost forgot that, and next call, okay? There's a problem here before we move on. What happens if we are at the top row and we minus 1, right? Then there's no other row. So it would be undefined, which means that the next bit, trying to figure out the column on an undefined, will throw an error. What we do is right between these 2 square brackets, these 2 opposing square brackets, we put question mark dot for a little bit of optional chaining, okay? So if If we find that we either found a T or a G, right, travel or goal, then we're going to enter the loop. But before that, we need one more test in here, and that is to make sure that we aren't about to go in the opposite direction. Again, if we go down the first time, we don't want to go up on the very next step. So we need that, which means that we need to get that trail. We're going to peel off the last character on there and make sure that it is not equal to the, sorry, not the D, but the O for the opposite direction. Okay. A couple of ampersands in there to make sure that it is this and this. It's not the opposite direction, and we've found it at this position. Okay. With that, we update all of our variables. So trail plus equals D, right? Because we are adding to the trail. We're going to do that. The next one is the current coordinates. Just like this, we're going to set that equal to. Notice we aren't doing plus equals. That doesn't make any sense here. It's an array. But we're going to go next row and next column, okay? And then the current type is technically all of this. So equals this, but we can get rid of the question mark dot because we've already tested it here. If we enter this if statement, this is guaranteed to exist. At least that's my hope, right? That's in testing, it seems to work that way. In practice, test a lot because you are inside of a while loop, okay? Now, the last thing here, okay? What if I'm going through these and it's like, oh, you can go up. Problem solved. Do I want to loop through the other three when I've already found up? Absolutely not. So the last thing right after all of this stuff is a break, which kicks us out of the for loop and lets it go to the next iteration of the while. At this point, everything should work, and it absolutely does. So that's a bit of a weird one today, right? Where we are navigating this matrix-like thing. It's not a true matrix because it is an array of strings, but we can start anywhere inside of here. And because there's no branching, if there was branching, we'd have other problems, right? But because there's no branching, we only have a one shot, okay? It starts here, ends here. There's only one true path through the thing, and we just need to test around it. And that's what we've done. So yeah, we set up some variables. We found our starting position, set up some other variables that we change as we go through. Those are down here. And then we entered this while loop. And the nice thing about the while loop is that it's, because of the nature of this system, it's only guaranteed to do as many iterations as there are letters. So for this one, this was 6 letters, which means our while loop will only loop 6 times. This one here, the very last one, I think it was 17. I'm not going to count it right now, but our while loop will only go 17 times. And then inside of there, with that for loop right here, we're guaranteed to only go 4 times, or because we have the break here, less, right? As soon as we find one of these matches, we kick out of the for loop and go to the next step, okay? Now, the last step is, I said I would come back to why I did it this way, and the reason is to make this flexible. So I can go options equals an empty array, and then on the bottom of this, I can spread options, if I can spell it right, options like this, which means that if I sent in an options object that only had travel, maybe I change it to an A for advance, right? Well, then everything else just works, right? I still have access to C and G because those weren't changed. The only things in options that can change are things that are already here, or we're adding stuff and we don't care about anything else. So problem solved, okay? But it makes it very flexible to use this in different versions of this, okay? That's it. And again, it was a bit of a weird one, right? With the while loop and the for and doing some stuff, and of course how we tested it. Again, not every solution, just hopefully a pretty good solution, right? If you disagree with that, hit me up in the comments. If you want to show me your solution, definitely hit me up in those comments. I want to see it. Otherwise, for today, this has been Trail Traversal, which is a mouthful in itself, and I will see you tomorrow.